All right, in this lesson, we are going to be looking at fractions, and later on at adding and subtracting fractions, but first of all investigating and kind of manipulating fractions to do what we want them to do or what we're being asked to do. So this will be divided into two separate lessons. So we're going to be going over parts A, B, and C in this lesson, and then if you look in YouTube for the next lesson, you'll find it there as well. Okay, so two lessons. So the first thing we're going to look at is how to reduce fractions to lowest terms. So what fractions do is they represent parts of something. So one reference that I would have for you is, let's just think about pies or cakes. So a lot of the fractions that you're going to be seeing in this lesson look like circles because the cakes that I eat and the pies that I eat look like circles. So if we look here at this example here, 6/12 is represented as a picture with that pie right there. So I shaded in 6 out of 12 parts. The denominator, or the bottom number, represents the number of total parts, and the numerator, the top number, represents how many parts are shaded. So 6 out of 12. What you'll notice is, and we'll be getting into this shortly, and write these down as we go here, is each of these actually represent the same fraction. So 6/12 is also the same amount of pie as that picture there. Although it's broken into less parts, it represents the same amount, which is the same as that here. So we're going to be looking at how to reduce fractions to make them mean the same thing, but to be using smaller numbers. So to reduce a fraction to lowest terms, we divide the numerator, which is the top number of a fraction, and denominator. And you might want to pause this video if you're not very familiar with fractions. Pause this video and rewind it and look at it a few times. That might help you, but by a common factor until they don't share a common factor anymore. And another key idea is that decimal numbers are not allowed as we're reducing fractions. So 6/12. What it means by reducing this is what numbers go into 6 and 12, both of them. You could think of a variety. Actually, 2 goes into 6 and 12, so does 3 goes into 6 and 12. And 6 also goes into 6 and 12. For the purpose of my example, this isn't the only way to do it. I'm going to say, okay, I know that 3 goes into 6 and 12. So if I want to reduce this, 6 divided by 3 is 2, and 12 divided by 3 is 4. And do you notice that this here is 2/4? I've shaded in 2 out of 4 parts. So it's equivalent to 6 out of 12, but the numbers are smaller. But that's not as small as the numbers can get. So 2 and 4, I can actually divide those each by 2 because they're both even numbers. So 2 divided by 2, the numerator divided by 2, is equivalent to 1. And 4 divided by 2 is 2. And what you'll notice is that that's 1/2. Okay, and 1/2 is the lowest terms. There's nothing that goes into both 1 and 2 without making them into decimal numbers. So that's 1/2 is the lowest terms of that fraction. In some cases, it's hard to draw a pie for reducing fractions, so we want to just get into the numeracy. You would not want to draw 105 out of 135 pieces of pie or cake. So given what we previously learned, you have to sort of know your times tables and what factors or what numbers go into the numerator and denominator. We know that 5 goes into anything that ends in a 5. So if we, first of all, if we want to reduce this fraction, if we divide those each by 5, and you're allowed to use a calculator for this, 105 divided by 5 is 21, and 135 divided by 5 is 27. 21 and 27, sometimes they can't be reduced. In this case, if you know your multiplication table, and again, you might want to pause this video and work ahead and challenge yourself here. 21 and 27 both have a common factor of 3. So 3 goes into 21 7 times, and 3 goes into 27 9 times. So that's your lowest terms. We reduced 105 out of 135 to 7/9. All right, the next topic is expressing mixed numbers as improper fractions. So again, I'm going to use pies and cakes here, and you're going to look at the first example. Then I'm going to give you some shortcut steps here. But what I'm noticing here is this is 3.5. Okay, and I have broken, because the denominator of 2, so that denominator of 2 represents how many parts to break each pie into. So I have a whole bunch of pies here. I've got 3 whole pies and a half of another pie. So I've divided them all into 2 parts, and I hope you'd agree that this is here 3.5. Now what an improper fraction is it represents this 3.5 pies not using a whole number. So in other words, how many halves, and let me count them for you. There you go. There are a total of 1, 2, 3, 4, 5, 6, 7 halves. So 3 1/2 is equivalent to 7 halves. That's just another way of writing it without a whole number, and that's useful in the future. You may be asking yourself, how can I do that if I don't have a picture? So let's pretend that that picture was gone, because sometimes you might have pictures that have really big denominators, like 8, or even bigger denominators that you have to figure out just numerically. So first thing I'll say is to calculate the numerator of the improper fraction. What you're going to do is multiply the whole number and the denominator and add the numerator of the mixed number. Okay, so what that means is to get this 7, what I'm actually doing is multiplying the whole number by the denominator. Why? Because I've got 3 groups of 2. That's where the 3 groups of 2 come from. And then plus 1. So I add that guy. Okay? So multiply the whole number by the denominator, so 3 groups of 2, and then plus 1. And we know that 3 times 2 plus 1 is 7. That's where I'm getting that 7 from. And the next thing in your key ideas is the denominator of the improper fraction doesn't change. So the denominator doesn't change. It is the same as the denominator of the mixed number. Okay? So you can challenge yourself on this next one. I can also show you with the picture, but to make this into an improper fraction, the first thing we know is that 4 5/8 is still a certain number of eighths. Okay? And you notice here that I actually have 4 whole pies divided into 8 parts, and then 5/8 of another one. So that's 4 whole pies, and 5/8 of another. So how many eighths in total is that? Well, the first thing that we know is that it is 4 groups of 8. That's this here. That's 4 groups of 8, and then plus 5 on that extra pie, so adding 5. So to get that numerator, it's 4 times 8, which is 32, and add 5, which is 37. So another way to write this is 37 eighths. Okay? So 4 groups of 8 plus 5, or if you'd really like to, you could count every single one of the eighths of the pie here, and you notice you get the same answer. Okay, so you'd have 1, 2, 3, 4, 5, 6, 7, 8, and then you'd have blah, 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 blah. This would get you all the way up to 16, 24, 32, or in other words, 4 times 8, 4 groups of 8, and then add 5 more, and you'd have 37. So there's 37 eighths of that pie. Okay, the last part of this lesson is to do the reverse. It's expressing improper fractions as mixed numbers. So what you'll notice here in this example, and then the next part of the lesson will be saved for a second YouTube lesson, because this one's quite long and you might want to pause it and work ahead. Some of you may know the answer to this next one. So 7/3, what I've done here is I've broken up these pies all into 3 parts, because the denominator always represents what we divide them into. Okay, so I divided a whole bunch of pies into 3 parts, and I shaded in a total of 7 parts. So here's 1, 2, 3, 4, 5, 6, 7. Okay, so that's 7/3. Now I want to represent this as a mixed number. So in other words, how many wholes, and then what's the remaining fraction? So what I actually notice here from the picture, if I shade in 7/3, is that not two whole pies? It is. And then what's remaining, that there is just 1/3 of a pie. Okay? So 2 wholes and 1/3 remaining. Another way to do this, and this is what I'm going to get into the steps, because sometimes you're not going to want to draw things like 31/7. You'd have to break up a pie into 7 parts, and you'd have to do that with a whole bunch of pies, which is totally possible, not a bad thing to do, and then shade 31 of them to know how many whole pies and how many parts of a pie are there. But I want to give you a shortcut or a different way of doing this. So the first thing we're going to do is divide Or you can do this in your head. A lot of you who are stronger with your mathematics and numbers know how to do this stuff in your head. So divide the numerator by the denominator. As long as you're getting the correct answer and understand the concept, you'll be absolutely fine. So using long division. So for example, 3 goes into 7 2 times. The quotient, or number on top, is the whole number of the mixed numbers. So what that means here is if 3 goes into 7 2 whole times, that's the whole number part. So we've got 2 wholes, because 3 goes into 7 2 whole times. Next, we're going to continue with our long division. The remainder is the numerator of the mixed number. So if you look at the long division here, 2 times 3 is 6, and the remainder is 1. So that remainder tells us what's remaining. If 3 goes into 7 2 times, there's 1 remaining. What you'll notice here is that that 1 is the remainder, or in other words, the numerator of the fraction. So let's write that down. The remainder is the numerator of the mixed number, and the denominator of the improper fraction is the same denominator of the mixed number. So if you look at this next question, if you think about this holistically, it might be a little bit easier, and a lot of you do this in your head. What you're actually doing is putting 7 into 31. So 7 goes into 31 4 whole times. You can skip count, 7, 14, 21, 28. So it goes in 4 whole times to make 28. So actually that 4 whole times is the whole number, and the remainder, so 31 minus 28 is 3, that remainder is the numerator. And remember, the denominator just stays the same. So 31 over 7 would represent 4 whole pies, 4 whole times, with 3 remaining out of 7 parts.